Hello everyone, my name is Richard Jang, and I'm a technical marketing engineer here at Cisco's Wireless Enterprise Networking Business Unit. I'd like to welcome you to episode 3 of a 4-part series on the Cisco Aironet Active Sensor. In today's episode, I will be going over the sensor test creation and deployment workflow. First, I will be going over the 6 different test categories we can configure, the details behind what they're testing, and the pass-fail criteria for each of them. Then, I'll follow this up with a demo in regards to how we can create and customize a sensor test template. Lastly, I'll continue this demo to include details regarding how to deploy this created test template to your desired sensors on Cisco DNA Assurance. Starting off with the first category of tests, we have onboarding, in which we have association, authentication, and DHCP tests. During these 3 tests, the Aironet Active Sensor will associate to your wireless network the same way any wireless client would. The purpose of these 3 tests is to ensure that basic client onboarding is working properly. If the sensor is able to join the wireless network and receive an IP address in a timely manner, the test is considered a pass. For the second category of tests, we have RF assessment, in which we have a data rate and an SNR test. During these 2 tests, the sensor will be analyzing the data rates established with your wireless network, as well as the signal-to-noise ratio of your RF environment. The purpose of these 2 tests is to ensure that the environment in which your APs are serving clients is up to optimal standards. If the sensor determines that there are no outliers in the data, the tests are considered a pass. For the third category of tests, we have network services, in which we have a DNS and a radius test. Starting off with the DNS test, the sensor will attempt to initiate a DNS lookup to a hostname you've provided through Cisco DNA Assurance. The purpose of this test is to ensure your DNS server is operating as expected. If the sensor is able to resolve the defined hostname through your network's DNS server, the test is considered a pass. As for the second network services test, we have the radius test, which consists of 2 parts. Part 1 is that the sensor will act as a client authenticating into an 802.1x security network, using a username and password you've provided on Cisco DNA Assurance. Part 2 is that the sensor itself will actually act as the authenticator and connect to your radius server through a user-defined shared secret and port number, the same way a wireless LAN controller would. For those of you who are not familiar with this process of authentication, the prerequisite to run this test is to log into your radius server, create a device entry with an IP address or range that includes your sensor's IP, then define a shared secret which will allow for a secure channel of communication between the authenticator device and the radius server. In addition to the shared secret and port number, Cisco DNA Assurance also allows a user to customize the radius protocol used for authentication. Users will either have the choice of using PAP, which stands for Password Authentication Protocol, or CHAP, which stands for Challenge Handshake Authentication Protocol. In regards to PAP, you can think of it as a regular login procedure in which a client will authenticate itself by sending a username and password to the server in plain text and having the server compare it to what's being stored within the credentials database. However, there is one downside to PAP, and that is it sends the credentials in plain text, and this results it to be vulnerable to cybersecurity attacks such as eavesdropping or repeated trial attacks, making it a potentially unsafe technique for authentication. This is why CHAP was invented. In regards to CHAP, you can think of it as a more secure version of PAP, and one example of this includes protocols such as MS-CHAP v2. For a high-level definition, during this protocol, the authenticator will send a randomly generated challenge string to the client along with its hostname. The client will then use this hostname to look up an appropriate secret, combine it with the challenge, then encrypt the string using a one-way hash function. The result is then returned to the server along with the client's hostname, and the server will perform the same computation and determine if the client has arrived to the same result. However, CHAP itself also has vulnerabilities, and that is the username is still exchanged in plain text, and the password is only hashed in MD5, meaning nowadays, a hacker can technically grab the username, obtain the hashed password, then use both together to run an offline dictionary attack to brute force the password. With that being said, for both radius protocols, it's recommended to only run these tests over a WPA2 enterprise-based WLAN, which encrypts all over-the-air content. Coming back to it, the purpose of this test is to ensure that your radius server is functioning properly in all angles. If the sensor is able to 1. Authenticate itself as a wireless client, and 2. establish a secure channel of communication with the radius server as the authenticator, the test is considered a pass. For the fourth category of tests, we have performance, in which we have an NDT, an IPERF3, and an IPSLA test. Starting off with the NDT test, which by the way stands for Network Diagnostics Tool, the sensor will send an HTTP query to retrieve the information of either one, the nearest public MLab server, which for those of you who are not familiar with this topic, has the characteristics of being a globally distributed and embedded load balancing mechanism, or two, a user-configured private hosted MLab server, both of which the sensor can support up to an NDT5 version. Using the information retrieved, the sensor will then run a throughput test to the server using TCP port 3001, analyze the data collected such as the throughput numbers and latency, and determine if they're within a reasonable range. The purpose of this test is to determine whether your network is in an optimal state to support high throughput and low latency, and if both of these criteria are satisfied, the test is considered a pass. For the second performance test, we have the IPERF3 test, which is newly introduced in Cisco DNA Center 211. In this test, we have the ability to run throughput and load balancing tests to up to 25 private IPERF3 server instances consecutively. Similar to the NDT testing, the purpose of this test is to again determine whether your wireless network is in an optimal state to support high throughput and low latency. If all data is within a reasonable range, the test is considered a pass. For our last performance test, we have the IPSLA test, in which you'll be provided with the option to choose between different service levels, such as Platinum, Gold, Silver, and Bronze, which will determine the type of packets sent during performance testing to the access point. For those of you who are not familiar with what service levels are, these are the options that at a high level correspond to packet priority, which behind the scenes is defined by WMM, which stands for Wi-Fi Multimedia, as well as DSCP, which stands for Differentiated Service Code Point. The purpose of these values is to ensure that the applications that require higher throughput to operate properly receive higher precedence. To provide an example, a Platinum service level is of high priority and corresponds to voice packets because voice over IP applications require the lowest latency and retry rate to refrain from a degrading quality of service. The same idea goes for a Gold service level, which corresponds to video priority, Silver, which corresponds to best effort, and Bronze, which corresponds to background. Whichever service level is selected, the sensor will conduct a performance test using the packets of that priority and analyze the data for jitter, latency, packet loss, and round-trip time of last hop. If you're familiar with wireless, you'll know that it's not uncommon for a client to send packets marked with the wrong service levels. But when this happens, we want to understand how our network will react to it. The purpose of this test is to provide the ability to test either the best possible scenario, which is when the client is sending packets with the same service levels as what you configured in your network, or the worst possible scenario, which is when the client is sending packets with a service level of anything other than what you've configured within your network. With that being said, if the analyzed numbers described prior are considered to be within a reasonable range, the test is considered a pass. Moving on, for our fifth category of tests, we have application, in which we have a host reachability, a web, and an FTP test. Starting off with a host reachability test, this one is rather straightforward in the sense that you simply provide the sensor with an IP address through Cisco DNA Assurance, and the sensor will attempt to reach it through ping. The purpose of this test is to provide you with the ability to monitor whether critical applications within your network are up and running. You can configure the sensor to test multiple hosts during this test. And through Cisco DNA Assurance, you'll be able to easily monitor the availability of these applications. If the host you've provided is reachable during the time of the test is considered a pass. For the second application test, we have the web test, in which you would define a URL and the sensor would attempt to reach it. The purpose of this test is to monitor 1. Whether certain web applications you could be hosting are up and running, and 2. The latency and response time for each of these web services. If reachability to the provided URL is successful within a reasonable time, the test is considered a pass. For our last application test, we have the FTP test, in which a user must define the IP address and credentials of their FTP server. Then, select a transfer type of either upload or download as well as a path within the server. In regards to the download option, your sensor will attempt to download a file from the path you've specified. In regards to the upload option, your sensor will attempt to upload a file pre-built into the sensor to the FTP server. The purpose of this test is to monitor whether or not your FTP service is functioning as expected in all aspects. If the upload and/or download to the specified path or file is successful, the test is considered a pass. For our sixth and final category of tests, we have email, in which we have a POP3, IMAP, and an Outlook Web Access test. Starting off with the POP3 test, the sensor will attempt to connect to the POP3 server you've defined through port 110. The same is done with IMAP, except through port 143. The purpose of these two tests is to ensure that your email service is reachable through the ports they should be reachable on. If both servers are reachable by the sensor through the described ports, the test is considered a pass. For our third email test and final test overall, we have the Outlook Web Access test, which for example refers to email services such as Microsoft Outlook Web Access, but as a disclaimer, doesn't include Office 365. This test requires a user to provide an Outlook Web Access URL and corresponding credentials. The sensor will then attempt to reach the server URL and attempt to both log in and log out of that server. The purpose of this test is to ensure that basic functionality of this email server is working. If the sensor's login and logout process is successful, the test is considered a pass. Now that you have an in-depth understanding of each wireless test the sensor is capable of running, let me quickly walk you through the high-level workflow of how these tests are created and deployed. The sensor test creation and deployment workflow is from a high level a two-step process designed in a way to allow test management to be incredibly easy. Starting off with step 1, which is the sensor test creation workflow, on Cisco DNA Center, we first initiate the sensor test template creation workflow through the sensor management page. From here, we can first choose the SSIDs we'd like to test, which includes both Cisco and third-party SSIDs. In the next step, you'll then be provided with the ability to select the tests we've been discussing and that we'd like our sensors to execute. Then, you'll be given the ability to define the scope of the test coverage by defining parameters such as the band, number of APs, and RSSI we'd like our sensors to execute these tests in. Upon completion, you can then review your inputs and confirm the intent of creating this test template. And now, step 1 is completed. Moving on to step 2, we have the sensor test deployment workflow, in which we'll be given the ability to deploy the template we've just created either within locations or to specific sensors. Upon selecting your target test location, you can then choose the frequency in which you'd like your test to run. Again, upon completion, you can review your inputs and confirm the intent of deploying this test template. And now step 2 is completed. With that being said, you now have an end-to-end understanding regarding how we can go from creating a test to deploying it to our target location. Let's jump into a demo where I'll walk you through exactly how these concepts are executed on Cisco DNA Assurance. When we initially log into Cisco DNA Center, we'll end up at this homepage. In order to create sensor test templates, we want to navigate to the sensor management page. We can do so by opening the menu, clicking on Assurance, then Sensors. Here, we can click on Test Templates at the top, then click on Add Sensor Test to begin this test creation workflow. The first step of creating a sensor test template is providing a template name, which I'll enter in Cisco Test Template. Then, we can specify the SSIDs we'd like our sensors to test. On the left, you can see we already have a list of SSIDs, and these are actually all pre-populated by Cisco wireless LAN controllers that are managed by this Cisco DNA Center. As for on the right, it'll allow you to add an SSID that's from a controller that's not managed by Cisco DNA Center. And this opens up a whole new realm of possibility, as you can now leverage the Aironet Active Sensor to test legacy wireless Cisco networks, wireless Meraki networks, and even non-Cisco networks. However, while majority of the sensor functionality would still be available if this option is chosen, a couple of features specific to Cisco networks managed by Cisco DNA Center are not, and this includes the IP SLA test discussed earlier, as well as the neighboring AP view, which we'll discuss in the next episode. For the purpose of this demo, I'm going to go ahead and select 3 auto-populated SSIDs of different security levels: Open, PSK, and 802.1x, as well as configure 2 third-party SSIDs, with the first one security level being PSK, and the second one being 802.1x, then hit Next. On the following page, we can now enter in the credentials for our chosen SSIDs. Observe that for my Open Security SSID, in addition to the default Open option, there is also an IceGuest portal option. If I click on it, it'll open this modal box that would allow me to specify details regarding an IceGuest portal or whitelist if I desire. But for the purpose of this demo, let's go ahead and leave our open SSID with the default open setting and enter in the credentials for my PSK and 802.1x SSIDs. Now that I'm done, we can go ahead and hit next. We've entered the test selection page, and as you can see, these are the exact same tests that we discussed earlier in this video. And when you select multiple SSIDs for a single template like we've done, Cisco DNA Assurance will allow you to configure custom tests for each SSID. However, for the sake of this demo, let's go ahead and only configure additional tests on my Cisco 802.1x SSID and just minimize the other SSIDs and leave them with the default tests. To get started, for the first two categories at the top, we have onboarding and RF assessment. As you can see, all tests in both categories are by default enabled and don't require additional parameters to be added. As an FYI, for the RF assessment category, both data rate and SNR tests acquire these RF KPIs from other non-boarding tests. So in order for us to get RF assessment results, we need to make sure that we at least enable one test in any of the categories below. For our third category of tests, we have network services, in which we first have DNS. When selected, you will be prompted to enter in a host name to be resolved. Let me go ahead and enter in cisco.com. Under this same category, we have radius, which I'll be entering in my radius server's IP, which in my case is 172.27.75.145. Below, I'm entering in the shared secret I've defined within my radius server when registering my sensor as an authenticator. Then, I'm entering in a port number for authentication, which by standards is 1812, a username, and password registered to a user within the radius server, as well as selecting a radius protocol, which we have the options CHAP and PAP. Let's go ahead and leave it as CHAP. For our fourth category of tests, we have performance, in which we first have internet, otherwise known as NDT. When selected, it'll provide me with an option to either leave the input field blank, which will have it conduct performance testing to a public MLab server, or an option to enter in a private NDT server, if so desired. Let's go ahead and leave this input field blank and use the default settings. Next, we have iPerf3, which when selected, prompts us to specify an iPerf3 server IP to test, which I'll be entering in 172.27.75.121, which is my iPerf3 server. Then, it'll allow us to customize the UDP bandwidth as well as the start and end port numbers. A single iPerf3 server can have a start and end port range of 5, and by clicking on the Add button to the right, you can enter up to 5 iPerf3 servers. This means we can actually configure a total of 25 server instances for testing. In my case, let me go ahead and just change my end port to 5205 to have my sensors test 5 different iPerf3 instances with my single iPerf3 IP. As an FYI, anytime you see an Add button on this page, it means that multiple parameters such as servers within one test can be added for consecutive testing. Last on the performance test list, we have IP SLA testing, and as discussed earlier, will allow us to choose one of these 4 service levels: Platinum, Gold, Silver, or Bronze. As a disclaimer, it's crucial when selecting one of these service levels that you know which service level you've already configured to use within your network. With that knowledge, you can make a conscious decision to conduct performance testing to your network with packets of matching service levels or not. In my case, my network is configured with a Platinum service level, and I'd like to performance test it with the same. For our fifth category of tests, we have applications, in which first we have host reachability. When selected, it'll allow me to enter in an IP address. Here, I'm entering in 172.27.75.201, which is one of my VM applications that I use at work every day. Next, we have web testing, in which when selected, it prompts me to enter in a URL. Let me go ahead and enter in https://cisco.com. Last on the application test list, we have FTP, which when selected, prompts you to specify the IP address of your FTP server, whether you'd like to upload or download a file, the path where you'd like to upload or download a file, as well as your username and password. Let me go ahead and enter in the information for both the download and upload scenario of this test. For our sixth and final category of tests, we have email, in which we have POP3, IMAP, and Outlook Web Access. For all 3 of these, when selected, I'll be prompted to enter in the email server IP, and for the case of the Outlook Web Access, a username and password as well. For POP3, let me go ahead and enter in 172.27.75.165, which is my private POP3 server. For IMAP, let me enter in 172.27.75.166, which is my private IMAP server. And for Outlook Web Access, map.gmail.com, which is a public Outlook Web Access server, as well as my username and password. Now that we've configured all the tests on this page, let's go ahead and hit on Next. Here, we have our AP coverage page, where we can define exactly how much of the RF surrounding the sensor we would like to execute the tests on. We can specify the band, 2.4 and 5 GHz, the number of target APs, in which we can select a maximum of 5, as well as the target RSSI threshold, which will define the range of the RF signals our sensors will test. Let's select both 2.4 and 5 gig bands, 5 target APs for each band, and leave the RSSI threshold as default. Once completed, we can go ahead and hit Next. We have now entered the test creation summary page, and at the top of the page, you'll notice that there is an estimate time section. This time is calculated based on the number of tests and AP coverage criteria you've configured earlier. Naturally, if we configure more tests and/or a larger AP test coverage, which we've configured quite a lot, the test will take longer to complete. Looking below, you'll see it summarizes what we've configured in the previous screens. Confirm the sensor test template is as desired, then hit Create Test. Now that we've created our sensor test template, let's go ahead and deploy it. If you've just created a sensor test template like we did now, go ahead and click on Deploy Test to Locations to enter into the deployment workflow. However, let's say we want to deploy a test template we've created earlier. We can do so by navigating to the Sensors Management page by opening the menu, clicking on Assurance, then Sensors. Then at the top, click on Test Templates to enter our test template page, which includes a table of every test template we've created. Here under the Locations column, next to the test you would like to deploy, click on Deploy Test. On this page, you'll have the option to specify the areas you want this test template to be deployed to. If I click on Global, it means I intend on deploying this template to all sensors on my Cisco DNA Center. Similarly, I can choose to deploy it to a specific building or floor. Let me uncheck Global, expand my San Francisco area, and click on the One Bush building instead, and you'll see my selection show up on the right. Now, if I only wanted to deploy this template to a few select sensors, I can unselect my San Francisco One Bush building, expand the building, then select the floor within. Here on the right, it'll give you an option to open up a sensor selection list by clicking on all sensors here to the right. By default, all sensors within that floor are selected, but through these checkboxes, I can select them based on the goals of my testing. If desired, you can even pre-program the test target AP per sensor by clicking on these drop-down menus beneath the target AP number column. The purpose of configuring this is to provide you with the ability to run tests against all APs on your floor and validate each AP's service status. I'm going to just keep this as default. As an FYI, you may be wondering what these yellow triangles are alerting us about. What's happening is that I already have test templates deployed to these sensors, so Cisco DNA Assurance is just warning me that by deploying this newly created sensor test template, it will overwrite the old. After you've made your selection, hit Save, then Next. Here, we'll now have the option to set a schedule for when we want our sensors to run the test templates. We have 3 options: periodic, scheduled, and continuous. First, with periodic, your sensors will run the test template based on the interval defined. Opening this drop-down menu, you can see we're able to choose from a frequency of running a test every 7 minutes to just once every 24 hours. You might notice that the first couple intervals are grayed out, and this is because the frequency timer will begin the moment the test template begins running, and our test template's estimated time already surpasses these. The interval must be longer than our test template's estimated time for it to be a valid option to choose. Second, with scheduled, you will be given the option to choose specific days and times that you would like to run your test. This is the most granular option, as it also allows you to select multiple times during a single day, as well as select the interval in which the test should be ran. Lastly, we have continuous, in which your sensors will run the test template non-stop 24/7 until manually stopped. As a disclaimer, it's not recommended to use the continuous setting for running any performance tests, as it could overload the network. A recommendation would be to use this continuous setting for when you initially mount the sensors and would like to get data flowing. But once everything appears to be working, switch it back to either periodic or scheduled. With that being said, let's switch it to periodic. Then hit next. Finally, we've entered the summary page. We can now review that these are the deployment configurations we've intended and hit deploy test to complete the test deployment workflow. With that being said, this concludes episode 3 of the sensor series. In the next episode, I'll be going over how we can now assess our wireless network's health in day 2 and onwards. We'll be doing so by going through the sensor dashboard and Sensor 360 page on Cisco DNA Assurance. In the case you run into any issues, we'll also be going over how to troubleshoot these issues. To view this video, please click on the link in the description below, and as always, thank you for watching.